The basics of combining functions are your basic operations on functions, which are addition, subtraction, multiplication, and division. A lot of times in math, it's the symbolism, the notation we have to get used to. Addition is simply the quantity f plus g of x. We can split this into f of x plus g of x. All we're doing is splitting and adding the two functions. Similarly, the quantity f minus g of x is f of x minus g of x. That's subtraction of functions. F times g of x is fg. Notice there's nothing between them. Please make note of this because we're going to look at something later which looks similar to this but is very different. F times g of x is f of x times g of x. And f divided by g of x is simply f of x divided by g of x. And again, we insist that g of x not be equal to 0. Let's look at an example. Let's look at f plus g of 2 if f of x equals x squared plus 6x and g of x equals 2x minus 7. We have two options here. We can either figure out what f plus g of x is first, and we know f plus g of x is f of x plus g of x. F of x is x squared plus 6x. G of x is 2x minus 7. When I combine those, I get x squared plus 8x minus 7. So f plus g of 2 is just this equation evaluated at 2. So 2 squared plus 8 times 2 minus 7 is 4, plus 16 minus 7 is 13. We could also split it up, and instead of figuring out the f of x plus g of x first, we can just do f of 2 plus g of 2. F of 2 is 2 squared plus 6 times 2, which is 4 plus 12, which is 16. G of 2 is 2 times 2 minus 7, which is 4 minus 7, which is negative 3. And 16 minus 3 is 13. A lot of you may say, well, why don't we just do it this way on the right? Sometimes this way on the left is actually much simpler. It allows you to actually work with the functions quicker and easier. You really need to be able to do both methods. Similarly, we can do f minus g of 2. We can do the same thing. We can do it this way with the f of x minus g of x. I will warn you, the one thing we have to watch out for on subtraction is we need to include the entire g of x function. We need to put it in parentheses or brackets, because this negative sign applies to more than just the 2x, it applies to the 7 as well. This becomes x squared plus 6x minus 2x plus 7. So we get x squared plus 4x plus 7. Again, evaluating x equals 2 gives us 19. Again, the same situation here. If we want to evaluate at 2, we get 16 minus a negative 3. It becomes 16 plus 3, which is 19. We have the product. Sometimes this is a lot easier on the product. F of 2 times g of 2. I didn't plug these in here because we already knew what f of 2 was. F of 2 from the previous two examples was 16. G of 2 from the previous two examples was negative 3. So 16 times negative 3 is negative 48. In this case, this is much simpler to do than this other way, because if I do f of x times g of x, I actually have to FOIL my two binomials. I get x squared plus 6x times 2x minus 7, and that reduces to 2x cubed plus 5x squared minus 42x. Again, we can evaluate this at 2. And again, you'll wind up with the same answer. However, you do need to know both methods, because sometimes this method is a lot quicker. Sometimes this method sets you up for things to be a lot quicker down the road. And finally, our division. Again, in this case, this method's quicker because we already know what f of 2 and g of 2 are. So this is just 16 divided by negative 3, which is negative 16 thirds. This one we actually do the long way. We plug 2 into each of these functions, and again we get the 16 divided by negative 3. Again, this is just notation. Don't get lost in the notation. Get very familiar with it and comfortable with it. Composition of functions. This is the one that looks like multiplication. This is f of g of x. It's read f of g. It's f with this little circle between it, and the g. It kind of looks like fog. The way we rewrite this is f with the g of x inside of it. Okay? Let's look at examples of this. F of g of 2, that's f of g of x. And instead of g of x here, I'm going to plug in 2x minus 7, because that's what g of x equals. So f of 2x minus 7, well, f was x squared plus 6x. And instead of x, I have 2x minus 7, so this is 2x minus 7 squared plus 6 times 2x minus 7. You're going to just FOIL this out. You get 4x squared minus 28x plus 49, plus 12x minus 42, which reduces to 4x squared minus 16x plus 7, and we evaluate this at 2, we get negative 9. This one's a little bit more interesting, and this is the one I want you to focus on, the f of g of 2. The g of 2 we already know is negative 3. So f of g of 2 is simply f of negative 3, and now we evaluate f at negative 3. This becomes negative 3 squared plus 6 times negative 3, so positive 9 minus 18 is a negative 9. Again, same answers both ways. Let's see how this applies when we do tables numerically. Remember, we've done symbolically. We want to look at tables. We're going to also look at graphing. Here are the functions I'm given, f of x, and I'm given various values of f of x, and here are my values of x. I'm given x as 1, 2, 3, and 4. The corresponding f of x values are 4, 3, 2, and 1. G of x is 2, 1, 4, and 3. And we want to fill in this table. Let's start with a few examples. F plus g of 2. Well, f plus g of 2 is f of 2 plus g of 2. F of 2 is 3, g of 2 is 1, 3 plus 1 is 4, so I'm filling in the table here. F divided by g of 2 is f of 2 over g of 2. Again, f of 2 is 3, g of 2 is 1, so 3 divided by 1 is 3. F of g of 2, again, we're going to rewrite this as f of the quantity of g of 2. G of 2, we already said, was 1. So what's f of 1? Well, f of 1, according to our table, here's x equals 1. F of 1 would be 4. Let's look at another column, some more examples. Let's look at f minus g of 3. This is just f of 3 minus g of 3. F of 3 is 2. G of 3 is 4. 2 minus 4 is negative 2. F of g of 3 is f of 3 times g of 3, which is 2 times 4, which is 8. And again, the interesting one, f of g of 3 is f of the quantity g of 3. G of 3, again, is just 4, and f of 4 on our table is 1. Here, which you can also see in your handouts, are all of the table filled in. We can also evaluate combinations of functions graphically. Here, I'm given this red line is my f, the green line is our g. And I want to find f plus g of 2. F of 2 is 5. G of 2 is 0, so 5 plus 0 is 5. F minus g of 2 is 5 minus 0, which is 5. F times g of 2 is 5 times 0, which is 0. F divided by g of 2 is 5 divided by 0, which is undefined. And finally, f of g of 2 is f of g of 2. G of 2 is 0. F of 0 is 1. So g of 2 is 0. Let me rewrite this in here so we get a better sense of it. F of g of 2 is f of 0, which is 1. And again, we need to be able to use both the tables and the graphs.